Good evening, everyone. Hi, I am Ankur, architect Ankur Kulkarni. I'll just quickly introduce myself. Uh, by qualification, I'm an architect, but I practice as a sustainability consultant. And I graduated in 2006, followed by my master's into sustainability in 2008. And actually, that brought my interest more into building services. And then I worked with a company called Spectral Services for 5 years. And then I started on my own. So before I start or before we move on, I sincerely would like to thank Tata Tiscon for giving me this platform and opportunity. And today's topic is little technical, close to my heart. This we practice on a daily basis, sustainability and high performance building design. So as we progress, any questions comes to your mind, please write to me. At the end, I'll share my email ID as well as my mobile number too. But in between, if you come across any questions or if you have any doubts, please send it across. And once we are done with our presentation, maybe next within 40 to 45 minutes, yes, I'll try to answer maximum of them. So thank you again, and let's start with the today's session. Uh, I'll take you through few case studies which we have done. So to explain the concept in a simple manner or fashion, it is very important to measure the performance. When we say high performance building design, it mainly comprises of your, of course, needless to say, energy performance, but your shadow analysis, daylight ventilation, heat island effect, wind analysis, everything is very important. So before you freeze on your design parameters, it is very important that how you tackle or deal with your passive technologies and strategies. So this is a first step, that shadow analysis, and this is a typical standard requirement of a high-rise committee, especially in MMR and Mumbai region, where your building, if it is the height is more than 70 meters, then the first and prima facie requirement is that your proposed design should not cast any shadow for more than 2 to 3 hours on the surrounding buildings, because it is clearly considered as the sun axis is your birthright. So in case if you are enjoying a good sun from east and west sides, but because of the proposed buildings which are coming up in future, if that is getting blocked, then it is not acceptable. So mainly the shadow analysis is carried out on 3 different days. One is of course your 21st March and September, that's equinox, 21st of June where the sun angle is at a very higher altitude, and of course 21st December where the altitude angle is little, not little, comparatively low, and the shadows get casted on a longer length. So yes, this is our project, one project, and these are the few proposed buildings, and we were supposed to analyze whether this proposed development is getting any negative impact in terms of daylight and ventilation on the surrounding structures or no. So we actually built the entire model. This is in Low Parel in Mumbai. With the yellow colored buildings are our proposed buildings, as well as if you see all these other gray colored buildings are the surrounding buildings. And the idea, the intent was to check the impact or negative impact or shadow impact of the proposed buildings on the surroundings one. So yes, this is the first slide of showing the results and impacts of 21st March, then yes, 21st of June, and then 21st of December. So combinedly, if you see, then this is the final list. So say for example, the building number 25, it is G plus 11, and it is almost getting an impact of just 7 to 8%. So roughly the acceptable range is somewhere close to 30 to 35%, maximum 40% as per BRE standards, that is British Research and Establishment. But if you are below than that or within the limits, then it is absolutely acceptable. In fact, you can very well check out our article on this specific subject, that setting up the shadow analysis parameters for tropical regions. Maybe I can share that article with you as well. So yes, this I would say a first and foremost step when you say a walk towards a sustainability or high performance building design. Then this is again a very interesting analysis which we did, because if you see this image, in this image, this is a small building, this is a school building. I'll just show you that in plan as well. So this was our proposed building C1, and that school building, that 39 building was here. and because of the height, it was completely getting shaded. It was completely getting shaded. So what we actually proposed to the architects is, we tried to reduce the height of this building so that the minimal shadow will be casted on this, and these floors were adjusted on the previous, or I would say जो पीछे वाला building था उसके ऊपर. So this is a very interesting concept, so that you can actually check whether one building is casting a shadow on the other one and whether it is actually blocking a daylight or no. And yes, of course, based on the sun path analysis, you can clearly have a exact calculation behind that. This is again a second project. Similarly, we did it in Mumbai region only, and here the challenge was totally different. The ventilation was not an issue mainly, but the daylight was very, very critical, because the height of two buildings was 70 meters and the distance between two buildings was just 6 meters. So this is a plan. This is building number one. This is building number two. Both the towers with height of 70 meters, and the distance between two is just 6 meters. And when we actually did the facade radiation analysis, only this portion, just see this elevation part, only this portion was getting radiation somewhere close to 4,000 to 5,000 watts per square meter. And this entire almost 70 to 80% of your total elevation was shaded. ये बीच वाला portion, ये यहाँ पे. So our challenge is to get that sunlight or get that radiation wala part on every apartment or every facade. So the first step what we did is, we checked our setbacks and we requested architects, and yes, he agreed to it, and we increased the distance between two by just 3 meters. That was the best possible option, or that was the best possibility to increase the distance. So 6 meters ka 9 meters kiya. And if you see this image again, previously almost 80% of your elevation or the flats were shaded, but here almost 10 to 15%, I would say, increment is there. If you compare this previous image, now see this, so it has been increased, because just by widening the distance, or I would say gap between the two buildings. The next step was, we opened building at refuge levels, so at 7, 14 and 21st. So those floors, instead of having just one block as refuge floor, we kept it open and made it through and through. Because of that, what happened, actually it helped us to increase our ventilation rate, as well as we had some reflective surfaces on those reflective floors, or I would say refuge floors, sorry, not reflective, refuge floors. And then we introduced light shelves also there. So this actually helped us to bring in more light and light on the elevational part. So this is the next. So this was my total unshaded area. This is the diffused light penetration because of the opening of those refuge floors. But still we are, I would say, the 50% problem solved, but the 50% is still as it is. And then of course, introduction of the light shelves, this also helped us a lot. And the most important is this reflector strategy. So what we actually did is, based on your sun path, your angles, we introduced this sun reflectors on these buildings. So how it is going to work, if you can see this section, it is a combination of convex as well as concave mirrors. So mainly the sun rays are getting reflected by this convex to this concave, and then it is getting reflected back into that well. This is a very simple section. This is, you can easily have it. The only thing is, we have tested or tried this into a small model, but I'm sure at least 50 to 60% success rate will be there when we will actually install it on a building. And at the end, yes, this is how it works. So we have two reflectors in between, and then these convex mirrors. So whatever the sun rays falling onto this, it is reflecting back to this reflectors and then into this well. And this way, at the end, previously the lux level within that setback area or well was somewhere close to 7 to 8,000 lux. Even the NBC says that minimum lux level requirements for a warm and humid climate on a cloudy sky should be at least 9,000 lux. And with this exercise, we have been able to achieve somewhere close to 15 to 20,000 average, 15 to 20,000 average lux level within the well. So yes, this could be a next strategy. So when I say ki high performance building design, yes, your mechanical systems are important. Air conditioning, without a doubt, is very important. Pumps, motors, insulation, efficiency, double glass, low E, everything is important. But what should be the first step? First step is without a doubt your passive strategies. Because if you try to reduce your demand, if you try to reduce your needs, then only you will be able to optimize your system. अगर पहले से मैं कोई ढंग का एक डिजाइन सोचूं, तो उसके वजह से हो सकता है कि 150 के बदले मुझे 100 टन का मशीन लगे, एंड देन यू थिंक कि वो 100 टन का मशीन कौन सा मैं अच्छा ले सकता हूँ, व्हाट एल्स आई कैन डू. बट द फर्स्ट स्टेप मस्ट बी to reduce your demands and needs and heat gains and loads. So yes, that was something interesting exercise which we did. Yeah, so this was the overall scenario. So before, this was the before case, 70 meters, two towers, and just 6 meters distance in between. And this was after 6 meters was increased to 9 meters. Then yes, we opened up it at two levels, at refuse levels, but through and through. We introduced light shells. These two surfaces, your ceiling and flooring in those refuse floors was completely treated with high reflective materials. And at the end, we introduced this solar reflectors, a combination of convex and concave mirrors on the top, so that it can direct sun rays and penetrate into the well. Yes, and yeah, these are few images of the studies. तो आपको ये स्केल से पता चल सकता है कि यहाँ पे एक टेंटेटिवली 20 से 22,000 लक्स का रेंज है. This drops down here and goes around 1700 or something, and this is just 5,000 to 7,000. But if you consider average is at least 13 to 15,000 lux on the entire facade. Yes, so outside lux level available is around, let's say, 15,000 or something. And even if I use a glass of VLT of 50 to 60%, then at least I'll be in a decent position to have minimum 800 to 900 lux with near the windows, and at least 100 to 200 lux towards the wall or the corner. Yes, the same sun path analysis. Then this is again a different case study of wind and ventilation studies. We typically do it for three different types. One is average minimum speed, one is average speed, and one is average maximum. So average daily low, average daily high, and average. So what does that mean? So if we check Mumbai weather file and we extract the data from it, so this is Mumbai's average daily wind speed, which is 2 meters per second, and the average low speed is 0.54 meter per second, and average daily high is somewhere close to 4.16 meter per second. So when we do a wind analysis just to check the ventilation, as well as, yes, of course, it is not only the ventilation. Yes, I would like to make it one point very clear that this is purely from the pedestrian comfort level, purely from the perspective of pedestrian comfort, as well as your ventilation requirements. And let's not get confused with this wind analysis and the other one which structural designers perform, because they do it by considering for around 40 to 44 meter per second. In fact, this is not even a wind tunnel test also. This wind analysis is only where architects can play with their masses, the positions of the buildings, and of course your pedestrian comfort and ventilation. So yes, if you see the screen now, average wind speed by considering 4 meter per second, and then if we do the analysis, so these are those 5 proposed towers, this is the cell buildings, and again here you have those 2 different towers, and this is again a rehab wala portion, and we did it at different levels. So this is at 2 meters, this is at 45 meters. So now you try to relate, this is at 90 meters. So what we are trying to show here is at 90 meters by considering this surrounding and Mumbai climate. Sorry. Yeah, so at 90 meters, this yellow color depicts somewhere close to 3.5 to 4 meter per second. 3.5 to 4 meter per second is wind is blowing from this side. Because of this development, it is getting little blocked. And if you see here, the color is I would say blue or green, which is around 1.5 to 2 meters per second. So the idea was to make sure that every apartment or every single household should have minimum wind speed available near their windows, so that they can match the NBC requirement of air changes per hour. I'll show you some 3D images also. Yeah. So this was the main problem. So with this C-shaped building, and if you see the well, this entire portion, it was getting a wind speed of maximum 1 to 1.5 meter per second, which is not bad, but still, as a sustainability consultant, the challenge is always to check whether is there any possibility to increase it or no. So again, the best thing what we did here is, I'll show you those uh, plans as well. So this was a one rehab building number 3, and if you see this yellow colored portion, these are the, or I would call, refuge floors. So these refuge floors, instead of placing like this, we proposed with this new design. So this was a previous design, 1, 2, and here 3 refuge floors. And if you see this portion, so what we did, we moved one portion on this side so that I can have a through and through refuge floor here, and also one here, so that from here also you can get a complete wind speed. So this was building number 5. ये पहले वाला डिजाइन था, यहाँ से एक फ्लोर निकाल के we put it here so that I can get a through and through opening here on every 7, 12, 21, and after that 29 as well, because this is my southwest direction. And if you compare this portion, यहाँ पे एक भी opening नहीं था. So what we did is, we removed one flat from here and we proposed it to make a refuge floor on this side, west. So this is my west and this is my southwest. And if you see this model, this is 3D model, you can see that because of that punctures, a little bit increase in the wind velocity is easily observed. So this is somewhere close to, if you check the scale, was around 1 or 1.5 meter per second, but this yellow portion is 2 to 2.5 meter per second. See, if you refer this scale, this, yeah, not 2.5 also, so 3 to 3.5 meter per second. So that was an interesting analysis. And yes, so these two towers, it is not only that you should increase the wind velocity. Sometimes it becomes very challenging and difficult if you are getting wind more than 4.5 or 4.8 meter per second also. So you have to little bit control that wind speed also. I'll just take you through this Beaufort scale. I don't know whether you can read it or no, but maximum comfort range would be till gentle breeze. So gentle breeze is known as 2. Not known as, but gentle breeze can be considered if the wind speed or velocity ranges between 2.4 to 3.8 meter per second. But the moment it goes beyond 3.9 per meter second, though it is called as moderate breeze, but still the impact is it raises dust, loses paper, and hair discomforts. So yes, I would say below or above 4 meter per second wind, you may feel that little discomfort is there, and you may tend to close the windows कि यार थोड़ी जोर से हवा आ रही है, थोड़ा window बंद रखते हैं. So what you can, how you can tackle this problem, how you can do interesting facade designs or analysis on this. So actually आर्किटेक्ट बहुत ही क्रिएटिव थे, उन्होंने कुछ इस तरह से हमें फसाड करके दिए, so that the pattern, the continuous wind which is flowing from the west and southwest, so जैसे ही वो आपके फसाड पे आके टकराए, वो थोड़ा सा डिस्टर्ब हो जाता था. Yes, so that disturbance helped us to reduce the wind speed as well as pressure also. So these are few different strategies which we had proposed. You can have the different treatments on your facade, but at the end this design was final. Yes, two to three main beams they were extruding from the facade, and also a combination of acrylic devices or shading devices. This actually helped us to reduce our wind speed and pressure too. And if you can compare this, so we studied for two cases on, sorry, not two cases, two different buildings. So this is case 1 where we are comparing the pressure, and the bottom images of velocity and point A and point B. So point A is somewhere close to minus 13 Pascal or something, because it is going on a negative side, where the wind velocity at point A and point B is averagely around 6.4 to 7 meters per second. But with the introduction of this design, or I would say vertical fins and horizontal sections, it actually dropped down from 6 to almost, this yellow color is somewhere close to 4.8 to 5.6. So itna reduction to kar paye because this is at a very higher level. This is somewhere close to 180 to 200 meters or something. Yeah, so this was the final calculation. So 4 points we had considered: A, B, C, D, and pressure and velocity. So point B previously noted was 6.1 and after effect was 4.8. So at least there was 20% drop of 20% drop in the wind velocity because of this suggested elevational treatment, which is fair enough. And of course the ventilation calculations. So this is very important exercise. So I'll show you just one simple example. Let's say I'm talking about this flat near the point A, and here you have a living room, kitchen, and bedroom, and all these three habitable spaces or rooms are having close to 2.4 to 3.2 meter per second wind speed near their windows. So yes, the first step would be your area. So living room area is around 25 meter per 25 square meter. Then window area which is 4.4 meter per square, 4.4 square meters. Then window operable area, because yes, since we have sliding windows, maximum 66% would be openable. So that is 2.9, because 3 track channel ho to 66% open ho jayega. Average required air changes per hour is 4.5, because NBC says 3 to 6, so average is 4.5. And based on this calculation, if you need to convert it into equivalent cubic feet per minute CFM requirement, and wind speed available outside, minimum requirement was 0.1 meter per second to achieve the air changes of 4.4. And here if you see, the wind speeds are available close to 1.8, 2.1, somewhere it is lesser than that, somewhere it is higher than that. And at the end, every room was getting air changes per hour more than 30, 40, 50. Yes, without a doubt, because this is a high-rise building, so wind speeds are available, wind speeds were available, so we didn't face much issue. But this analysis can be done for a small buildings also, maybe G+4, G+5, or those buildings which are surrounded by dense development, so that this wind analysis can actually help you to predict what is the wind speed available outside my window, and then my window size or my window opening, whether it is sufficient to take care or to meet the air changes per required as per NBC or no. Yeah. Then of course, the next step was daylighting analysis. So when daylighting analysis, the baseline was we performed the analysis. This is a standard requirement. If you refer to any green building certification methodologies or guides, IGBC, LEED, GRIHA, more or less they'll talk on a similar lines that your working plane should be from 2.5 to 3 feet. You do it at 12 o'clock in the noon on equinox day, either 21st March or 21st September. Then you should have some analysis grid. Define your glass VLT, that is visible light transmission, whether it is 40%, 50%, and do consider your surface reflectances, the reflectances from your floor, wall, and light reflectances basically, and ceiling. So yes, so based on these parameters, in this project we had used two different glasses, VLT of 45 and 66, because we just discussed a few apartments which are facing that well side, a little radiation, or I would say direct sun ingress issue was there. So that's why internal courtyard facing all the windows having 66% VLT, and the external outside, the windows were having VLT of 45%, and the flooring reflectances 30, 50, and 70. And again, for daylight factors, these are the standards by SP41, that kitchen should have daylight factor of 2.5, living room of 0.625, study room 1.9, yeah, and circulation spaces 0.3. And one daylight factor is roughly close to 80 lux to 100 lux. So if you convert it into lux level requirement, so living room is 50, bedroom 1 or study room or bedroom is 152, and kitchen is 200. And against that, this was the scenario. So say for example, if this is a living room, so living room is getting average lux level of 260. और एक छोटा सा यहाँ पे व्यू बनाया था कि जस्ट एक आइडिया आ जाए कि एक्चुअली ये होने के बाद दिखेगा कैसे. So this will give you a clear idea if somebody may not be able to read this diagram. So this is a 3D visualization for you. So 300 lux, 400 lux, actually वो visualize जब करेंगे तो दिखेगा कैसे. So every apartment is getting a decent amount of not decent, but as per the thresholds and requirement. So these are few apartments: 1 BHK, 2 BHK, 3 BHK, various building, different wings. Yeah, again, this is a very interesting case, and this is a major issue, especially in MMR region, if you're working on an SRA project, because there's a standard practice or design that all the toilets in SRA projects, most of the times they face towards the corridor side, and kitchens they are facing to the external side. But this is a better situation. But in this project, it was exactly reverse. So kitchen were facing your corridor side and toilets were outside. So if you see the first image, this is my corridor side on my left, and this is my exterior side. And toilets were facing exterior and kitchens were facing your corridor side. Because of this, what happens that kitchen don't receive a good amount of good quality of light and ventilation, which was a basic necessity or need. On the contrary, there was a myth or there was a misconception that nobody will maintain toilets properly, so the hygiene issues will be there, odors and any other issues. So let's keep the toilets on the external periphery and kitchens inside. But with a strong I would say request or उनको convince करके finally हमने उसको change किया, and we just simply reversed it, we just flipped it. So now the kitchens are on the external side and toilets inside. So this also made a huge difference. So in first case, kitchen was receiving hardly 50 to 60 lux level, but in the next case, kitchen is crossing the threshold of 200 lux as per SP41. Otherwise, it has to be minimum 300 to 400, considering cooking as your activity. So here the kitchens are getting 300 plus. So everybody one please आप ये जरूर ध्यान रखिए कि अगर SRA डिजाइन हो, SRA बिल्डिंग का डिजाइन हो, तो किचन्स बाहर जाए और टॉयलेट्स अंदर आए. That's very important. Then yes, heat island effect studies. This is also very interesting and important. And the idea is what Ministry of MOEF, Ministry of Environment and Forestry, their demand, as well as high-rise committees in Mumbai, they demand कि with the effect of your new proposed development और जो भी कुछ आपका proposed development हो रहा है उसकी वजह से जो वहां का heat island effect नहीं बढ़ना चाहिए. Whatever the ambient temperatures were previously, make sure that you are close to that, more or less. At least 10-15% आपका ऊपर नीचे हुआ तो चलेगा. So this is the basic simple calculation methodology, depending upon the what are the different strategies you are using to reduce heat island effect. हमने यहाँ पे काफी सारी चीजें, mutual shading से तो benefit होता ही है, but your landscaping, water bodies है, treating your exposed roof surfaces, either you cover them or have a greenery on top, or china mosaic या white color paint से उसको treat करो so that they can reflect sun rays back to the atmosphere. This helps to reduces your heat island effect a lot. Similarly, whatever parking, no exposed parking, entire parking was completely covered either into basement or stills. Entire building was painted with a very light colored, ताकि उससे भी heat island कम हो जाए. Wherever possible we had to introduce we introduced grid pavers. And again सब लोग बोलते हैं कि grid pavers टूट जाएंगे if the fire machine or fire engine comes on it, but it easily can take or sustain a loads up to 40 tons. So वो भी अभी issue नहीं है. In fact, we changed the color of the roads. Instead of gray, we chose to go with a very light gray colors. So grid pavers, light albedo, high albedo roads, light colored facade, shaded parking, landscaping, mutual shading, water bodies, terrace के ऊपर आपका चाइना मोज़ेक और ग्रीन का कॉम्बिनेशन. So with all these strategies, and of course Miyawaki forest, इस particular project में एक छोटे से इसमें, this is a new concept, I'm not an expert onto this, one landscape consultant actually introduced this, but this helped us a lot to reduce the heat island, at least utne area ka surrounding ka. So that's why I've kept these two slides also. And at the end, previously if we compare, since this was an SRA project, the previously अगर हम उसका study करते हैं तो almost 6300 का radiation, incident radiation watt hours per square meter, that was it. And after all these studies, it dropped down to almost 5,000. So if you see the overall reduction was almost 18%. 18.7% was reduction into the incident radiation, and temperature drop was around zero point 0.1 degrees Celsius. And yes, this is also very, very important, performance evaluation, because all these passive strategies in mechanical calculations or science, 1 + 1 2 is absolutely, मतलब anticipate कर सकते हैं हम, performance guarantee दे सकते हैं, but irrespective of आप कितना भी अच्छा daylighting के बारे में सोचो, ventilation के बारे में सोचो, कई सारे डिफरेंट डिफरेंट सॉफ्टवेयर्स पे एनालिसिस करके देखो, बट अल्टीमेटली इट्स नॉट अ डायनामिक एनालिसिस, इट इज स्टैटिक. दीज रिजल्ट्स आर ट्रू एट वन गिवन पॉइंट ऑफ टाइम, किसी पर्टिकुलर डे पे, पर्टिकुलर दिन पे. दिस डजंट गारंटी अ परफॉर्मेंस राउंड द ईयर. सो द बेस्ट पार्ट वुड बी, जब भी कोई बिल्डिंग अगर कंप्लीट होती है तो उसका जाके आप एक बार तो सही पूरा ऑडिट कर लो. एंड फॉर दिस अगेन, दिस इज अ डिफरेंट प्रोजेक्ट. यहाँ पे हमने जाके अच्छे से स्टडी किया कि बिल्डिंग पूरा होने के बाद, दिस वी डिड ऑलमोस्ट 1.5 to 2 years बिफोर, वंस इट इज कंप्लीटली रेडी, कि व्हाट आर द लक्स लेवल्स अवेलेबल बिटवीन द टू बिल्डिंग्स. वी इंट्रोड्यूस दैट सोलर रिफ्लेक्टर्स, दिस दैट एवरीथिंग. तो लक्स लेवल्स के पूरे रिजल्ट लिए, yes, they are meeting our standards and requirements, because many studies, many papers, many articles, many readers, it shows that major problem of having or growth of TB into this SRA buildings is because of lack of light and ventilation. So this is a very, very critical issue, that how we can do this, or how we can deal with this in a better, efficient way. We went to each and every household. हमने घर में जाके भी readings लिए, that the numbers which we were claiming कि exactly वो 200-300 लक्स वहां पे आने वाला है क्या, और अदर आ रहा है क्या. And not only daylighting, we checked with the into corridors also, staircases also, refuge flows, wind speed भी अलग अलग जगह पे. What is the wind speed available on one tower, at ground level, at mid level, at top level. हर एक विंडो के सामने उस तरह से विंड आ रहा है क्या. what will happen if a different proposed building और कोई नया बिल्डिंग अगर उसके सामने आ गया तो what will happen. तो ये सारा सीन देख के उसके भी काफी सारे स्टडीज किए हुए थे. and this is at the end, the entire project was painted in a very light colored China mosaic. जहाँ पे है वहाँ पे रेडिएशन क्या होता है. so I'll explain you this. so this was direct radiation, and direct radiation was measured as 175 watts per meter square. So when 175 watts per meter square was incident radiation, और जब मैं उसको उल्टा देखता हूँ कि रिफ्लेक्ट कितना कर रहा है, तो 82. सो 175 जब इंसिडेंट हो रहा है तो 82 रिफ्लेक्ट होना इज ऑलमोस्ट 50%. हाँ, ऑन पेपर इट शोज कि 60-70-80% रिफ्लेक्ट होता है, बट थोड़ा मेंटेन भी करना पड़ता है उसको. यहाँ पे वो एटलीस्ट 50-60% रिफ्लेक्ट कर रहा है. और सेम चीज अगर आप यहाँ पे देखोगे, since this has a very dark color previs, the direct radiation was 77 but reflected was just 17. मतलब 77 में से 17 सिर्फ रिफ्लेक्ट हो रहा है और बाकी 60 एब्जॉर्ब हो रहा है. तो इसकी वजह से आपका हीट आइलैंड बढ़ता रहता है. सो सच स्ट्रेटजीज और ये मटेरियल्स को आपको थोड़ा सा जुडिशियसली सिलेक्ट करके यूज करना चाहिए. सेम विद द, इफ यू सी दिस टार रोड, डार्क कलर रोड, ये 50 वॉट्स पर मीटर स्क्वायर है, और अगर आप रिफ्लेक्टेड देखोगे इट इज जस्ट 6, because of color. At the same time, if you see this light color pavers, out of 100 almost 25% is getting reflected. Yeah. And yes, at the end, ECBC studies, because this was step one. I would call it as high performance building design, which consists of your heat island, daylight, ventilation, shadow, wind, everything. At the end, energy calculation. So we compared our buildings with ECBC also, with the whole building energy simulation method. And sorry, since this was a complete residential project, we compared it with ECBC 2007. Yes, ECBC 2017 is also there, but it clearly applies to your commercial buildings. and ECBC R is also launched, but that is still limited to only your envelope parameters. We wanted to have a check with the whole building simulation कि पूरा building किस तरह से perform कर रहा है. So we compared against ECBC 2007, and this project or this building saves around 2.5% over ECBC. You may feel that this number is very less, just 2.5% save कर रहा है यार, क्या फर्क पड़ता है? But this is against ECBC and not any other conventional or contemporary building. And our EPI is close to 94.3. So, sorry, ECBC EPI is 94.3 and our proposed case is 91.9. Yes, but there are many reasons and factors because the project is in Mumbai. Air conditioning was a basic need. And in fact, if you can see our schedules also, air conditioning we have considered here for at least 6 hours a day. So 11 to 5 in the morning. And this was comparison. Yes, all the external walls are AAC walls. Then every roof will have 2 inches of insulation. Glazing, glass is a single glass, but it has a U value of 4.6 into watts per meter Kelvin, HSGC of 0.42 and VLT of 45%. Shading devices, of course, I've shown you many elevational treatment sites. So definitely the entire effect has been considered here. LPD considered as 5 watt per square meter. Pumps and motor efficiency, IE2. External lighting load, we have been able to achieve at least 30% lesser over ECBC's Annexure 4. And domestic hot water, 30% of total hot water requirement is on solar. And apart from that, we have been able to put 60 kW of solar PV, which is 1% of your demand load. So with these parameters, my base case, so these are my base case results, and this is my proposed case, and the project is saving at least 2.5%. It's very minimum, marginal, but yes, 2.5% better than ECBC. And if we compare this with local, not local, I would say, but a regular building, then yes, the project saves or the building saves around 20%. So this project, if you compare it with the regular building, it's 20%, and against ECBC, because that ECBC is itself a very stringent case, it is 2.5%. And yes, of course, the renewable energy calculations, because based on different orientation, how you, so say for example, this is a south side. So south side, if you tilt your panel, then you will get a maximum efficiency. Also, the altitude angle should be equal to your, latitude of the city. Altitude angle, I would say the angle of your solar panel. So I'll just quickly take you through another project. This was mainly for the residential part, and this is a commercial project which we recently finished in New Delhi. We are just left with hardly 10 to 15 minutes. So I'll just quickly take you through this, and then we can have a question answer session. Yes, again, architect is from Mumbai, but the client is from Delhi. And same process, before we move on to our commercial or HVAC calculations, the first idea was to reduce the air conditioning load or heat gains. So Delhi, of course, composite climate. So there's a lot of possibility to have or to introduce different passive strategies, because at the same time, very important is your passive heating. Similarly, evaporative cooling. It may help for maybe 2 to 3 months, not much more than that. Earth air tunnel we tried to introduce here. So I'll just take you through quickly. So this is a climate analysis. This we did it on Ladybug, and it actually tells you that what are the exact comfort hours, or by introducing different strategies, how you are going to introduce your passive comfort level. So the first one, yes, just 16% of your total hours are comfortable. When I say comfortable, the thresholds are maximum 55% of humidity and temperatures more than 22. So 22 degrees Celsius, around 22 or 23, 24, and humidity up to 60, 55%, 55 to 60. So passive heating, then evaporative cooling, thermal mass and night purging, humidification sometimes, and desiccant dehumidification. Yes, we have introduced earth inner tunnel design here as well, only for a small common area, which is at a ground floor. And the temperatures which we received here were close to around 27, 28. But I'll be very honest with you that this unfortunately didn't had much success because of many issues. We faced a lot of condensation issues once we did with it. But yes, at least for 1 or 2 months, we have been able to achieve temperatures of pre-cooling of air of around 27 to 28 degrees Celsius. Evaporative cooling, yes, this definitely worked very well, but again only for 2 months. We have done it here for 15th March to 15th May, just 2 months. And that was also used only as misters in their outdoor area, just to have the outdoor comfort. So when the outside temperature is close to 40 degree or something, with the misters and evaporators, only for those 2 and 2.5 months we see or we observe the temperature drop of around 10 to 12 degrees Celsius here. Yes, this is again interesting because architect was very, very keen to have a double skin facade. The idea is to, of course, create a nice play of light and shadow. Similarly, it should reduce our heat load by having this jali, because jali effect is very, very important to reduce your heat gain. But at the same time, because of passive heating, we kept this few, if you see this 3 4 different windows, we kept it little open, welcoming the sun exactly perpendicular to the sun position, कि जब मुझे विंटर मंथ्स में सन चाहिए, तब ये 3 विंडो से, ये 3 4 विंडो से जो अच्छे से पूरी तरह से अंदर चाहिए, और जब समर मंथ्स में मुझे उसको ब्लॉक करना है, तो उस टाइम पे ये पूरा मेरा जाली उसके ऊपर एक कोटिंग की तरह काम करे. Then yes, अगेन वेरी इंटरेस्टिंग स्टडी एंड एनालिसिस कि बिल्डिंग का शेप ही भी इस तरह से बनाया कि वो म्यूचुअल शेडिंग करता जाए. मतलब अगर समर सन है तो मेरा टॉप फ्लोर नीचे के सारे फ्लोर्स को शेड करे, बट जब विंटर सन पे जाता है तो वहां पे वो डायरेक्टली परपेंडिकुलर बने सनरेज और पूरा का पूरा अंदर आ जाए. एंड वो पूरा देख के ही ये जो पूरा प्रोफाइल है वो उसी तरह से बनाया हुआ है. If you see these two images, we were very keen to not to have actually glare बिल्कुल भी अंदर नहीं आना चाहिए. So basically 2 3 different glare types of glares are there. One is direct radiation, so sun rays falling on your roof is also considered as a glare problem. And the second thing is contrast ratio. So say for example in the same room, if one corner is getting a lux level of around 2000 and the other corner is, let's say, 50 or 100, so that contrast ratio also causes a glare. So here what we thought is, not thought basically, but here we what try to deal with is, this is a problem. यहाँ पे ये direct sunrays आ रहा है, this is a problem. जाली लगाने के बावजूद भी एकदम जब low altitude angle होता है, when the sun is actually parallel to your east and west side, तो उसको deal कैसे करें? Of course, heat island, wind के studies. I'll come back to that point again because I left it in between. Daylighting part. Yeah. So this fritting on glasses actually help us कि यहाँ पे है, this is a, ये पूरा का पूरा यहाँ पे glare आ रहा है, तो उसके ऊपर थोड़ा सा फ्रिट किया तो उससे काफी फर्क पड़ा. And also it helped us to reduce our heat gain load also. So we'll come to that part. So this is a comparison again. For external wall, yes, we are going ahead with 6 inches external AAC walls. Same 2 inches of XPS insulation on roof. Glass, because of this is a commercial property, yes, we are going ahead with the double glass of HSGC around 50% and VLT around 50%. This is a comparatively clear glass, 50% VLT. HSGC is also 50 because more clear, more light will come in. And at the same time, we have our outer skin jali facade, so which will reduce our heat gain. So at the same, so that's the reason we have been able to use the clear glass, क्योंकि उसके सामने otherwise वो dark tint हो जाता और हमारा VLT drop हो जाता. Shading devices, of course, jali. LPD we have been able to achieve till 8 watts per meter square, that is 0.8 watt per square feet. Pumps and motors efficiency is IE3, of course. Process load is same both ways, 50 kW. Hardly few fire pumps and your lifts. No data server load is required. Ventilation requirement is 11 CFM per person as per ASHRAE 62.1 2010. Screw chillers have been used, COP with a 5.4. Efficient pumps and motors with at least 75 to 85. Variable airflow HVAC, all the H units with VAV. VFD on secondary pumps, yes. CO2 sensors to modulate the fresh air. Demand control ventilation, basically, yes, we are doing it. Heat recovery, no, we have not considered here. But free cooling, air side economizers, since this is a Delhi, December, January, and till around 5 to 10 Feb, the temperature, dry bulb temperature also drops below 65 degree Fahrenheit, or I would say 10 degrees Celsius or something, 10 to 12 degrees Celsius. At that time, we can actually keep our air conditioning off and take the direct benefit of that free cooling. So that's why air side economizers with a set point temperature of 65 degree Fahrenheit, that is also we are doing. CO sensors, yes, considered in basement. And yes, power factor correction of 0.97. And this, with this, so this was the actual countdown. So annual energy, this is a very interesting graph. I'll quickly finish it now. But previously, the area is around 1.5 lakh square feet, 1.5 lakh square feet ka hai. And if you just keep an eye on these three numbers, so annual energy consumption is 1800 anticipated through energy model, of course, 1800 megawatt hours. Total heat gain was 973, and HVAC का जो tonnage था वो 555, and this was a baseline case. Then we added a AAC wall to the building. Then heat gain was reduced to 944, and HVAC tonnage from 555, 555, it reduced to 538. And if you convert it into rupees savings, the savings of 3.84 lakhs. So again, this is very simple. So by introducing any new ECM, that is energy conservation measure, you'll be easily able to predict or calculate your savings in rupees. And then with the simple payback period method, if it is below 3 years, if your payback is below 3 years, then blindly go with that strategy. If it is between 3 to 5, then let the client take call. And if it is beyond 5, then I would say that strategy may not be recommended unless it doesn't have any maintenance cost or replacement cost after 5 years. So first ECM was AAC walls, then of course your roof insulation. Because of that, the HVAC tonnage was dropped down to 491, and energy savings up to 7.2%. Then the reflective envelope, then outer skin jali. Because of this also, there was a tremendous drop in the tonnage requirement. Total heat gain, also percentage energy savings rise up to 16%. Then the next ECM was WWR 50%. The previous design was with a complete glass. So since architect was sensible, responsible, he agreed to it, and we tried to limit WWR up to 50% only. Then selecting a right glass of HSGC 0.5. This again, इसकी वजह से savings 30% तक हो गए. और जहां से हमने शुरू किया था, we started at 555 HVAC. I mean, tons. Now it has been dropped down to 325. You can keep an eye on this number, 325, and this percentage savings. Also, this is a reduction in energy, and this is savings in rupees. Then, of course, DGU helped us to save further. Occupancy sensors, then your daylighting sensors, efficient lighting. We just saw that LPD has been limited to just 0.8 watt per square feet or 8 watt per square meters. Efficient equipments, then your chillers, efficient chillers, and then of course your efficient pumps and motors, VFD on secondary pumps, VFD on cooling towers. You will observe the fact that the moment we started with the HVAC part, my tonnage is not going to change, because ultimately we have tried our best to control our heat gain, and tried our best to reduce our HVAC tonnage also. So once we started with improvising our HVAC part, only we will save on energy, because that's an operational energy, and we may not be able to reduce capex henceforth. So yes, percentage of energy savings up to 48% because of VFD of cooling tower, VFD on cooling tower. demand control ventilation, air side economizers, CO sensors in basement. Air side economizers is the same thing which we discussed. Free cooling, the 65 degree height, 65 degree Fahrenheit wala concept, time based external lighting. And then we actually suggested our client to reduce or change the thermostat. So instead of setting a temperature at 24 degrees Celsius, can we maintain the entire building temperature at 25 and 26? So if you see the numbers, so this was my last, 51% energy savings, and savings in INR was around 1 crore 10 lakhs rupees per annum. अगर मैं यहाँ तक हमने 24 घंटे का ही टेम्परेचर रखा था, अगर मैं इसको 25 करता हूं तो ऑलमोस्ट 3 लाख रुपए मेरे बचते हैं. दिस 1 करोड़ 10 lakhs इज बिकमिंग 1 करोड़ 3 lakhs. और अगर मैं उसको 26 करता हूं तो फिर ज्यादा फर्क नहीं पड़ता है. तो इसका मतलब है कि वो सैचुरेशन पॉइंट पे आ गया होगा, बट 25 इज डिसेंट. सो यस, क्लाइंट हैज एग्रीड दैट द बिल्डिंग विल बी मेंटेन नाउ एट अ 25 डिग्री सेल्सियस thermostat, which is again a very good ECM. और फिर जो हमने PD, EC और EAT, अर्थ एयर टनल्स और पैसिव राउंड ऑफ इवेपोरेटिव कूलर्स का डिजाइन किया था, उसकी वजह से क्या फर्क पड़ता. सो ऑल पुट टुगेदर, night purging, at the end we have been able to achieve almost 1 crore 20 lakhs rupees per year, and total heat gain reduction was 55% total HVAC tonnage reduction was 57%, and total energy savings was around 55%. And of course solar panel पे roof पे solar panels तो लगाएंगे, वो भी लगाए थे. So yes, thank you. ये मेरे contact details है, mobile number और email ID. In case if you have any doubts and questions, feel free to contact me. Okay, there are so many questions. So I'll just organize this. I'll just ask organizers, can we take them offline, or maybe I can reply to them because it is 6 o'clock, or can we extend a little bit? All right. Okay, there's one question. It says, is this a part of BIM? No, because building information modeling is, I would say, a little different, and there you coordinate a lot with all your architects, engineers, all mode consultants. But this is more or less, I would say, a pre-design where the architect just starts with the concept. We come into the picture at that time, and when it reaches to a concept level, and then जब आपको GFC बनाना है, जब coordination actual शुरू होता है, so BIM helps a lot at that time. उससे पहले का ये काफी स्टडी है. This is very very, I would say, premature, because जब भी आप concept लोगे और करोगे, उसी टाइम पे इसके ऊपर स्टडीज कर सकते हैं. One question is it right that AEC block are useful more in hot climates and reduce the usage of air conditioning inside the buildings? Yes, the answer is yes, because AEC block, they have a resistivity almost 5 times more than brick. A typical brick has R value of around 0.2 in BTUs per inch, where AAC block, it has almost 0.8, 0.9 to 1 also. तो जस्ट ऐसा मान के चलिए, अगर आप एक 9 इंच का ब्रिक वॉल लेते हो तो उसका आर वैल्यू बनता है 1.8, और वही अगर आप 9 इंच का AC लेते हो, so the R value goes up to 8 to 9. So the performance is almost 5 times. So yes, AC blocks will definitely help you to reduce your air conditioning load. Yeah. There's one more question, that any direct benefit for going to such measures? Uh, of course, yes, because it makes sure that your building is well lit and ventilated. The heat island effect is reduced. You're making sure that every single room apartment is receiving correct amount of light and ventilation. Energy parameters से आपका bill कम होने वाला है. I mean electricity bill. So that is again a monetary benefit. So yes, ये भी very very important. Yeah. So one more question says, how much minimum distance to be kept within two towers to ensure proper light and ventilation? Proper air and light ventilations are managed to all levels of the floors within the towers, limiting 40 plus floors and above. Yes. I'm sorry, sir, but there's no direct answer or like a thumb rule, because every different, I mean, every building has a different characteristic. उसको एक बार study करना पड़ेगा, whether it is in Mumbai or Pune or Delhi, because it depends a lot on climate also. But just now I showed you the example, two buildings of height 70 meters and distance between two buildings was just 9 meters, but still somehow we had been able to fix the issues. But ideally, if you ask me, Mumbai HRC guidelines also says that distance between two buildings, if it is more than 20 meters, then you may not need to carry all these studies required, because 20 to 25 meters distance ensures enough amount of sunlight and ventilation within the two towers. But but again, depends case to case. But yes, you can consider 20 to 25 meters should be the minimum distance between two. I'll take this last question. Carbon credit concept applies to sustainable building. Uh, Fundamentally, yes, but practically would be very, very difficult, because if you compare buildings carbon credits with the industries, way beyond. If I mean, अगर industries में around 50% तो buildings से 1% भी नहीं होता. Also, because of the change in the policies now, it is very very difficult to sell carbon credits agar, by making sustainable buildings. In the industry sector, yes, it is working well, but nowadays the trending number is, what is your carbon footprint? So instead of saying my building saves 20% energy, my building says 30% water, saves 30% water, instead of that, go with a holistic approach where it talks about your STP, OWC, rainwater harvesting materials which you use, everything put together, and what is your carbon footprint. And if your building's carbon footprint is somewhere close to 1.7 or 1.8 only in the operational phase, then which is not bad, because that's India's carbon footprint is. So any building's carbon footprint is less than 1.7 or something, yes, I would say that's a good performing and sustainable building. All right, all right. Thank you so much. Thank you. Yes, and I think you have been able to see the screen. This is my mobile number and email ID. Feel free to write to me. I would be happy to discuss with you. Thank you. आपने मुझे बोला, लेकिन मैंने बहुत